Hello and welcome, a warm welcome to our 6th Rust Linz meetup. We are very glad that you are here and we are looking forward to a great meetup with two very great speakers and hopefully, I'm sure, very interesting topics. This meetup is brought to you by the Coding Club Linz, which is a coding community here in Linz in Austria. But we are doing this meetup in English because we have a pretty international audience and we are very happy about everybody joining us from around the globe here. Today's speakers, let me quickly introduce them before I will lead you through a few of community news, and then Carl will kick up today's Rust meetup. Carl is for the second time here at the Rust meetup. We are very glad to have him. He's a very active community member, and he will talk about unleashing the power of your comments in Rust. Then we have Aram coming up, who will talk about his work on Mosaic, a Rusty terminal workspace and multiplexer. We are very happy to have you here, Aram, and we are looking forward to your talk. The discussion, we would like to make it as interactive as possible, and we have chosen a Discord server for our platform to keep in touch and to do discussions throughout the meetup and also between the meetups. If you haven't joined our Discord server, you are very much invited to join it. Here you see the URL. Just enter this URL and you will be part of our Discord server. I will monitor the Discord server throughout this meetup, and if you have questions to our speakers, please type it in Discord and I will relay your questions to the speakers, and then we will definitely get interesting answers. Now let me conclude with a bunch of community news. Community news about IT communities in Linz or around Linz. And the first one is our very own Coder Dojo Linz. For those of you who don't know Coder Dojos are programming clubs for kids between 8 and 17 years. And we are running the Coder Dojo in Linz. Our next online meeting is tomorrow. We will meet tomorrow in the afternoon. We have a bunch of interesting talks. We are doing JavaScript development. We are doing some electronic stuff and a special workshop, as always in the last few weeks. Some of our mentors are building with kids a computer in Minecraft. So if that sounds interesting to you or for your kids, visit us at linz.coderdojo.net. We would be very happy to welcome you. We would like to announce the next study group of our friends at Female Coders Linz. Female coders are girls and females who would like, and women who would like to start a career in IT and software. And they are meeting at virtual study groups. And the next study group will be on the 27th of January. If you are interested, just Google for Female Coders Linz or visit this website and you will find their homepage. I would like to make a big shout out for the Microsoft Power Platform Bootcamp. Okay, granted, that hasn't so much to do with Rust, but still, I would like to announce this event because it is run by a few friends of us, very active communities in the IT community here in Linz. And yeah, if you are interested, take a look at 19th of February 2021. It will be there. And here you see the link, but if you Google it, just Microsoft Power Platform Bootcamp, you will definitely also find it. Our friends at Cloud Native Computing will do their 4th meetup also in a few days on the 26th of January. Take a look at their program. They always have very interesting talks and very interesting topics. Stefan and I are very proud to be Master of Ceremonies for a very special meetup coming up on the 27th of January. Contributing today will host a Rust meetup leading up to the FOSDEM 2021 conference. We have Rust heroes there, for instance, Nell Shamrell Harrington, Ryan Levick, who was already a presenter here at the Rust Linz meetup, Megan Lewis, who also did a presentation here at Rust meetup Linz, and we are looking forward to a very interesting evening about Rust. So if you want to listen to their talks, and there is also an Ask Me Anything session there, definitely check out their sessions and visit us at the 27th of January. If you are looking for the exact information about the time schedule and access links, go to contributing.today. You will find everything there. Last but not least, we would like to say thank you again to Microsoft. Microsoft is a regular sponsor of the Rust Meetup Linz, and we would like to say thank you for sponsoring us. And it is a pleasure for us to point your attention to the cloud transformation workshops that our sponsor Microsoft is offering. Here you see the link, aka.ms, discover Austria-Azure. If you are into the Azure cloud, if you do a lot of work in the Azure cloud, like for instance I do, definitely check their workshops. I think they're all free, or at least most of them are free. So even if you are a hobbyist or if you are a freelance developer, they definitely have some interesting workshops for you there. So again, thank you Microsoft for sponsoring the Rust Meetup. And with that, I am through with the community news. So let me stop my screen sharing for a second and let's invite our friend Carl on the stage. Let's ask Carl to unmute himself. Carl, are you there? Can you hear me?
Yes, hi.
Very well, nice. Carl, can you try to share your screen with us just to make sure that screen sharing works properly? We've tested it before, so it should work.
You should see the beautiful city Passau.
Yes, we see the beautiful city of Passau. Carl, we are looking forward to your talk. The stage is yours. Tell us something about how we can build great documentation in Rust.
Thanks, Rainer. So, okay, now that you said it, I realized that the title of my presentation is a bit overhyped, but it's a great topic, I think, really. So I couldn't help myself. I had to use this really cool animation, unleash the power of your comments. And this really is, I want to provide something for everyone, even if you're a beginner or if you're a long-term Rust user. I want to show some tricks everyone can use for the projects. So first of all, a quick note. We probably all know that comments are very important. And this is a very bad example of a comment because comments should add value. I'm saying this because I'm going to ignore that today. Because you can't teach comments by writing good comments. Or yeah, you can, but you can't teach about Rust doc by only writing good comments, or I would have not enough time. So why would someone talk about comments at all? I am the first to rant about it if it's missing. It's so important, and in my daily work I have to do with a lot of really old projects. Just today I discovered a dependency on a 2012 version of a library. So comments help me a lot, and I miss them a lot too in those old projects. But at the same time, I struggle with them. Good comments are really hard to do. And with Rust, it's always the ecosystem that gets the language even at one level up. So that's really important for Rust, I think, that you not only look at the language, but what's already there to help you build your things. Because in other languages, commenting was kind of an add-on. And for example, in PHP, you have various commenting systems, and there's some standard stuff, but every team does it a bit different. So it's great to see it's built in and you can rely on it. And I love reading a good documentation. I have a tip about one at the end of my talk. Okay, so I have prepared some code, well, rather documentation. I've prepared a workspace here, and this will be uploaded to GitHub, so you can look at it in your own time if you want to dive deeper into it. And let's just start with a really simple Rust doc comment. My font is so big, I can't fit the lines. You see here, we have, in the first line, we have 2 slashes. That's a classic comment. That's a comment you can just write anywhere, and Rustdoc doesn't interact with it at all. And if you use 3 slashes, then you have a Rustdoc comment. And this is attached to the main function. Now, this is great and all. I have my comments here. But what really makes it just that much better is that you get Rustdoc. When you install Cargo or the Rust default setup from Rustup, you get Rustdoc. And I'm using Cargo for this demo, but you could just use Rustdoc. So I'm going to execute cargo doc with the open parameter that builds the documentation and opens it in my default browser. I'm going to start a loop here, so it's just built in the background from now on. And all of this I get for free. I don't have to do anything to get this besides writing this one comment. I get my grades, I get a list of functions, I get some navigation, some pages, I even get a search. And this is a part of what makes Rustdoc so great, because you don't have to think about the next step. What libraries do I need to use to get a nice documentation? And yeah, so that was one of the points where I was like, whoa, this is just great. And it also explains why all the documentation of the online Rust stuff is so great, because you get so much help building it. Okay, this was just a really quick introduction. Those grades I built here built upon the one that came before. So I introduced a change in every one of those steps. The next thing I added was documentation for a module I'm writing. In this case, it's named MyMod. And here's something special. Because Rustdoc can see if you are using the 3 slashes or the 2 slashes with the exclamation point. And this is a top-level comment. And you'll see what I mean when I build it and open it in Rustdoc. Top-level comments are, well, on the top level of something. So you can provide a really quick overview over what's happening in this module in a main view of your grade. So users of your API can quickly see what's going on in there. And jumping really quick, I'm way quicker than I thought, into the next one. I added a top-level comment to the main.rs. And this is really cool. This is a comment for my whole grade. So I can write an extensive comment about what this grade tries to accomplish, what a user should be wary of, or something else important. And you can place it at the top of your documentation. And you don't need to clutter up some different files or include something, but you can. I'm going to show you how later. Oh, I don't think I do because it was nightly. Well, we see. I will talk about advanced features. Okay, so far so good. We have some great level comments, module level comments, function level comments, and here's something really clever. I guess you can guess it from the grade name. This is all just Markdown. And I didn't know I wanted this until I used this. Because sometimes in documentation, you need to emphasize. And it's easy to emphasize with Markdown. And we have some more benefits I will show later. So I think at this point alone, it's amazing what Rustdoc can do for you. It's really easy. It's really in the programming flow. You don't have to think a lot. And you get a really nice documentation out of it. Now, if you are a maintainer of some library, or you are a draconian product manager or something, I don't know, you can control a bit what you expect from the Rust doc system. So, for example, with this, it's called Linz, I think, you can just crash Rust doc when there's missing documentation. So everything, when you do this, everything in your code needs to be documented. Now, in real world situations, you would probably just warn about it. So you can just adjust that, like you could adjust any other warnings, for example, about you can get a warning about function names that have a big letter at the beginning, capital letter. And in the same way, you can control Rust doc. Yeah, so I'm going to show you how that looks in the browser, because again, it's all just Markdown. And that means those are nice code blocks, which are, I don't know if you can see it in stream, but they have a light gray background. So you can write code blocks in here, in your documentation, which is great. And that leads perfectly to the next step. We have some code samples we can put into the code. And let's jump into my mod here. So here you can already see Visual Studio Code is telling me to run doc test here. I'm going to show you what it does in a moment. When you put examples into Rust doc comments, you can just use the Markdown syntax you are familiar with, and then you just write Rust code. So you can show a user how to use your function, right? And for short functions, you can just make a doc test out of it. So I just said assert equal the value and 1, 2, 3. By the way, I'm just taking a string into here and making an unsigned integer here for a nice test. And I don't know if this code can run it. Let's see. No, it does not want to run it. I think I know what's the problem. Doc. Now, wait a second. So test. Okay, so I can, with a familiar cargo test command, which I can use for my other tests I've set up, I can just add the parameter doc. And when I run this, yeah, great. So one downside is it only works with libraries. I think I can, I have to say I want the lib, right. Great. Now that's working out great. Okay, so you can just run doc tests. And I had this working, I swear. No, that's not going anywhere productive. Sorry about that, but they do work for libraries. Wait a second, did I? No, I didn't include it. Maybe that's the problem. Cargo doc. It works, right? So that's what's the problem. The workspace wasn't aware of the package. And you can see it ran one test in my mod RS, and it passed. Ooh, cool. And you can, for libraries, even say that every public API needs to have a doc test or at least a code example. So that's another great way you can ensure the documentation of your project is up to your standards. And this integrates with the whole test suites. Right. Let's see, I've built this. I didn't. I'm going to start the loop again. So I documented a bit about doc tests in my documentation of this grade. Doc tests are a bit weird. You can only use it for public methods, and as you have seen, only for libraries. And there are some feature discrepancies with Rust doc and Cargo doc. You should try out what works better for you. I decided to fall back to Cargo doc because it has the lower features. And in my humble opinion, you should not use this to test whole modules. You should not use it to have a complex setup. It's great for those things where you have a one-liner or two-liner for some documentation, and you can just make a quick test out of it. And to make this even better in your documentation, there's a nice little trick. As you can see here, in front of the assignment of input, I've added a hashtag. Sorry, I know it's not originally hashtag. I don't remember what it was before. So I added the hashtag here and before I said equal. This may look a bit messy at this point, but if we build this and hop over into the browser, and then I'm going to my mod, and this is the documentation now for this function. Oh no, that's the wrong file. Great. I'm a bit stressed today. I'm so sorry, guys. Okay, here we are. So as you can see, Rust doc only takes the lines without the hashtags at the beginning into the code examples. So this is really great because you can use a variable to say, this should be some input by a user, or you should give me a hash at this point. So you can use a variable name here to say what you expect. And your code can still be just run as a doc test. But the user here doesn't have to worry about some assert in their code example because they don't care about your doc test at this point. Right, so I'm going to slow down a bit now. I'm going to jump into the last grade here. I have some more content on my slides. But this was, I really wanted to show this because it's powerful. We have, again, we have Markdown, and Markdown knows links, and I, of course, can set hyperlinks to anywhere. But Rust doc also has a special syntax for internal links. So in this case, this function should be should have a lowercase f at the beginning, but I decided I need to have this big F. Now, let's see. Yeah, so here a normal link is just a link. And this automatically links to the symbol named links, which is the module links. I should have thought about the naming a bit better. But you can, as you can see here, up here, if you just write my mod, it links to my mod. And when we jump back into here, you can see down here that this just works. You don't have to think about if you are linking to a module, a function, or anything else. But if you have to think about it, you can. You can say, this is a struct, this is a function, and sometimes it happens that in one crate, a name is used twice. So that's a great way to link to the correct item. Cool. So now that I run through all my crates, I want to showcase a search function again, because it's really great that I get this for free. I'm amazed. I even get some, if you're a dark mode user, you can also do that. And yeah, so that was the coding part. And now I'm going to jump back into my slideshow. And I have some more topics for you. Can you please start? Thank you. So some more goodies I want to talk about are the lints. I slightly touched on already. External files, aliases are really cool, and the Rust docbook. So lints, as I said, make sure examples exist or everything is documented. You can check for broken internal links. So if you have a bigger project with a few developers and someone is refactoring something and you link to it, it gets notified. You get notified in the building process because the link is broken, and that ensures your documentation is up to date at all places. And you can, even if you just want to document the public API, for example, you can check that no public API items are linking to private API items. Then we have aliases. I'm a really big fan of the search. I don't know if you noticed, but sometimes it's not it's not obvious that a name is not obvious. So, for example, you have a struct foo, but because of historical reasons, everyone just calls it bar. And for that, you can just use aliases for your struct. In this example from the Rust docbook, they used X and big as aliases for big X. So if you're searching for X, this struct also shows up. This is also great for refactoring. So if you're changing things around, you can set the old struct name or function name as an alias, and people can still find what they're looking for. Next up, wait, did I skip something? Why is my external files not here? Well, then talk about it. Then we'll talk about the Rust book now. The Rust docbook has some more advanced features documented. It has a detailed doc about all the options you have and some references. And I don't know where the external files slide went, but I can tell you that you can, at the moment, use external files, even with cargo doc, but you can't use them for the top-level comments. So I thought it would be really cool if the big markdown stuff I put on top of my crate was an external file, but that's not possible at the moment. They are working on it, and that's a really big point because I have a feeling it's a very active small community around Rustdoc, and they have a lot of open issues, and they have a lot of things in a pipeline which are really, really cool, like those external files, which are currently a nightly feature. So I would encourage you to just follow the project a bit on the side, or just look at it once, so you know what you can expect, because they have some really cool features planned. Wow. So thanks for listening. Here's the link for the Rust docbook. You can hit me up at carl@enough.coffee if you want to you will find a talk and the sources for my other stuff on github.com/Grasegger. I don't have a personal blog at the moment, but if you want to read something by me, I recently blogged about mindfulness on the company blog. Yeah.
Carl, thank you very much for this interesting talk. I learned a lot of nice things, and my special feature for today about docs is aliases. I've never heard about aliases, but they are immediately obvious to me that they are so useful. Thank you for pointing that out. We had some comments in the Discord server, not so many questions, but many people were blown away by some of the documentation features that you have shown, because it seems that we all do not so much like writing documentation, but now people get excited. So you did a great job. Thank you very much. We had a little bit of a discussion going on whether it is a good practice to add an assert statement inside of documentation, inside of doc tests. Do you have an opinion on that? Do you find them particularly useful? Do you use them sometimes?
No, that was just more of a showcase of what's possible.
Okay.
And not Matthias is completely right. Mm-hmm. It's more that you ensure your documentation is still up to date, so you can make sure of that. But personally, I use it for really small functions where I don't want to add config if and stuff. I know it's not the best thing, but it's something. Yeah.
So we shouldn't start writing our unit tests inside of Rust docs. But I think it might be useful just to make sure that the proper results that we expect in our documentation are still working. And maybe we have some references to the results of a documentation piece inside of Markdown, and then we can make sure with assert that the functions really deliver exactly that value. Mm-hmm.
I mean, it's the small stuff. I really used it for, because I already provided a sample. It's a line more, and I can have a test, and that's better than having no test, because I'm too hung up with not wanting to set up all the test infrastructure for it.
Awesome. Carl, thank you very much. Thank you for being a speaker at the Rust Linz Meetup for the second time. Thank you for being such an active member of the Rust Linz community. We really enjoyed your presentation. Thank you very much. Thank you. I'm pretty sure you will hang around on the Discord server in case of any further questions, will you?
Yeah, sure.
Very good. Very good. Thank you very much. Enjoy the rest of the meetup and have a very nice evening. We are looking forward to your third talk. Maybe in a few weeks you want to do another talk. You are always welcome as a speaker here at this meetup. Okay.
Thank you very much.
Thank you very much. And I will invite Aram to unmute himself. Aram, can you hear me? Yes, I see that you have unmuted yourself. Very good. Yep, and we can see you.
Amazing.
Aram, hello at the Rust Linz Meetup. We are very happy to have you here. Are you ready for your session? We are looking forward to it. Yes, you already shared your screen.
Yes, so everyone can see me.
Yep, it works fine. And the stage is yours. We are excited to have you, and we are looking forward to your talk.
Cool. Thanks for having me, first of all, and thanks, Carl, for this great talk. I was kind of generally aware there was this whole ecosystem of documentation with in Rust, but haven't had a chance to get into it, and I'm still at the stage of being blown away by Markdown inside comments. So very cool. Thank you for that talk. Today I'm going to talk to you about a project that I've been working on for the past 6 months or so. Mosaic is a terminal multiplexer and workspace written in Rust. A terminal multiplexer, for those who do not know, is an application that runs inside your terminal session and allows you to split your terminal session into several panes, each one of them a terminal. can also allow you to have like different tabs like you have in the browser, and also to maybe sometimes kind of detach from your current session, close your terminal window, and open a new terminal window and reattach that session. For those of you who have used Tmux or Screen in the past, both of them are terminal multiplexers, and Mosaic is a new one we are building right now in Rust. It's important for me to start by saying that I use like the plural sometime in this presentation because this project does not belong to me. Not just because ownership is theft, but because there is a whole team around this project. We are an open source project. We are 8 now. And while I started this project, I see myself now as part of the team. So shout out to all the Mosaic team. So in order to tell like the idea behind Mosaic, because it is not just a terminal multiplexer, I want to talk a little bit about what brought me to build it. And for that, I'll tell you a little bit about myself. So I started out my development career in operations, where I was a DevOps engineer. And most of the development I did was like writing Perl and Bash scripts. So the like editor I used in order to do that was Vim. Over the years, as I moved away from like DevOps into more traditional development, like software development roles, then I still kind of stuck with Vim, and this is the editor I use today to write any language like JavaScript, Rust, even some Python sometimes. So I kind of adapted a sort of system around Vim in order to allow me to use it as an editor and also do other stuff. At first, I used Tmux to have multiple like Vim panes and also a command line and such with the pane splitting. And then I eventually moved to i3. In case you don't know it, it's like, I think it's called a tiling window management. I saw it as taking Tmux and moving it to the desktop. So I'm able to open multiple terminal windows, each one of them having like the Vim editor open, command line like I was able in Tmux, but also having a browser window and such. This also allowed me to build like kind of an automation around it in order to have like automated tasks of having one pane, spawning other panes and such. Yeah, I guess I want to show this to you. So this is what I'm talking about. This is i3. We see here 3 terminal windows.
Aram, I'm sorry I have to interrupt you. You just share your slides. So we only see your slides.
I see. So I did not.
So maybe you should share your entire screen, because I think from what you are telling us is we should see something different.
You are very right. So let me just.
Yeah, you have just presented the Chrome browser. Maybe you have to stop screen sharing again and reshare the screen.
Just a sec. So, sorry about this.
Absolutely no problem.
Technical difficulties.
Yeah, we will master them.
So, let's see. Now I'm going to share my desktop. Do you see my desktop now?
Yes, we see the desktop. That's
Amazing.
correct.
So just let me bring the presentation back into it.
Yeah, we see the presentation.
And now you can see me switching tabs, right?
Yes, we see that. Works perfectly fine. Thank you.
Amazing. Thank you very much. Okay, so yeah, as I was saying, this is kind of my desktop environment right now. We can see 3 terminal windows here. Like in the middle, we see like an editor Vim window. And on the bottom, we see a terminal that I can use in order to run tests and look around the file system and such. And on the left, we see it's an application. In case you don't know it, it's called Ranger. It's a terminal application running inside the terminal that like lets you explore like the file system. I can go in, go back, go in directories and such. And then I can also like open files. What happens here is that Ranger kind of starts like a bash script, which talks to like i3, figures out the like the arrangement of the windows and figures out where to open like a new terminal pane. So you can do that like with a few panes. So this is what I used for development for a while. So this was nice, it's good, it's productive for me, but the problem is that like moving to a different like computer is something I fear. This is, as I alluded, this is kind of a soup of bash scripts right now. So it's a highly configured environment that's highly specific and not very transferable to other machines, not to mention other people. If I want to like to, if someone sees this and says, hey, this is cool, how do I work like this too? So this brought me to create Mosaic, which is getting back on topic. About 6 months ago, I quit my job for other reasons, and I decided instead of immediately looking for another one to sort of take this vision I have, this kind of development environment that I created for myself, and to like formalize it. By formalizing it, I mean to create an infrastructure that would allow me to describe this terminal and this development environment in a like configuration file, like a YAML file that would be brief and would like I would be able to transfer it to any other computer running that same infrastructure. So this is the basic idea behind Mosaic, and this is my goal with Mosaic. I think once we create this sort of infrastructure that we already have, then I will be able to use it in order to fulfill my needs. And other developers would be able to use it in order to build like their development environment or operations environments, or have like teams use it as a tool for collaboration. We'll get more into like the vision and what we can do about it later. But now, like the first thing I would like to talk about is like get into more of the technical side, because this is a Rust meetup after all. To talk a little bit about how a terminal multiplexer actually works. Multiplexer here is in parentheses because first I want to talk about how a terminal actually works. After we do that, and we're kind of on the same page about like the product we're talking about, then I want to talk about the internal architecture of Mosaic and how the different parts of the application communicate with themselves. And after that, I'm going to talk about the plugin system that we've built for Mosaic. We used Webassembly to build this plugin system. This would allow any developer to like write a plugin for all of this in any compiled language, be it Rust, Go, assembly script, or anything. And to have that be kind of a small applet within the application. For example, if you've seen the Ranger, the file explorer that I've seen before, our first plugin is a clone of Ranger that would allow us to run something like that within pane without having it to actually like, without it being forced to actually be installed on the computer that is running it. After that, I'm going to talk about the status of the project right now, like what problems we are facing and like what sort of challenges we want to solve. This is in case because this is an open source project, and as I said, multiple people are working on it. If this is something that interests you, then like these will be like a nice bulletin list of places you can like insert yourself in the project. So I want to show you the project itself and how it is now. And before I do that, I will mention that Mosaic is kind of in the early stages. So it's not 100% stable. I use it myself as part of my IDE. I use Mosaic in order to develop Mosaic, but it's not like 100%. So we are stabilizing it, but please forgive me if this crashes. So once you clone the project, you do a cargo run. And then we see, immediately you get command line, which is your default command line. Mine, the shell I'm using is fish. We get a command line, and as we can see here, I'll do the zoom annotate stuff. I always like that zoom opens the annotation thing on a completely different screen. Just a sec. Okay. So here on the bottom, we can see the status bar. So the status bar is part of the default layout of Mosaic. An interesting thing is that the status bar is a plugin. It was written in Rust, but compiled to WebAssembly, and then imported by default, as part of the default layout into Rust, into Mosaic, sorry. So here, it shows us the key bindings so that we don't have to remember all of the things that we can do. And I'll clear here. So zoom to give me my mouse back. And yeah, so if I do Control G, it gives us all of our current capabilities. We are able to split the window vertically, to split it horizontally. We are able to do all the terminal stuff, open a Vim window, scroll through it, and of course use the most important command line application. This is Mosaic right now, kind of similar to Tmux, but that's because we're looking for Tmux is our infrastructure layer, as I mentioned. So the first thing we're kind of doing is have feature parity with it to be able to do all the things that it does and build on top of it. So moving on, I'm going to talk, as I said, about how a terminal actually works. Forgive me if you already know this. I'm going to talk about a little bit of basic concepts. But please bear with me. I just want everyone to be on the same page. I'm going to go into more advanced topics that, unless you've dealt very deeply with terminals, maybe maybe they will be new for you. So first, what's the actual difference between a terminal emulator and a shell? Both are applications that run on your operating system and communicate with each other. The terminal emulator is the black window that you open in your operating system, black or white, depending on your theme. And it's in charge of displaying the text on screen, displaying textual user interfaces and such, and is in charge of the scroll buffer. So if you scroll up and down, if you had a long command and want to scroll up, that's the responsibility of the terminal emulator. The shell gets user input from the terminal emulator, spawns different processes such as top or ls, and sends its output to the terminal emulator with instructions of how to display it. Both of these are connected by the PTY. PTY stands for pseudo teletype, and it takes the std in and std out of the both the terminal emulator and the shell, and kind of fuses them together. So zooming in, the PTY is just a pipe, so it doesn't hold any actual state about what is displayed or what has been displayed and such. The only state that it actually holds is what the window size is. This is, there are some applications that run in the shell or that the shell defers to, for example, Vim and top that draw a textual interface and need to know how big they need to draw the interface, like how many columns and such. And this is something they can query the PTY. And the PTY can also send these signals back to the shell. Like there is like in POSIX system, there's the SIGWINCH signal that is sent to the shell and tells the shell that the window size has changed. This is also the responsibility of the PTY. It tells that it sends like operating system signals to the shell, and really it's just a pipe that fuses the two. So I want to take like an example of how the two of these communicate, and this will get us into the ANSI VT100 protocol, I guess one can call it, which is like the way the two of these communicate. VT100, by the way, in case you don't know, is the name of I think it was one of the first super popular physical terminal devices by DEC at the end of the 70s and 80s, and it kind of formalized a lot of these instructions that we're going to talk about. So let's take an example of how the shell displays like colored text on the terminal. The shell sends like this string to the terminal emulator. This is called a Csi Dispatch. Csi stands for Command Sequence Introducer. This tells the terminal to change the color to blue. If we look a little deeper into the like the CSI itself, we have an escape character, after which we have like a left square bracket, which is the way that the shell specifies that the CSI is starting. Then M at the end here is the kind of CSI. This is a styling instruction, and 34 is a parameter. It's like a function parameter. 34 tells the emulator to display the like the following text in what it defines as blue, because these are things that the terminal emulator can change itself. It's possible to send more specific instructions like with RGB and such, but for simplicity, I chose like the fixed stuff. After this, it sends like plain text, hello, and the terminal emulator displays it in blue. Afterwards, we have here another CSI, which tells the terminal that it's another styling instruction, this one to change the style to underscore. And then it sends world, and then world is displayed in blue and underscore. The important thing to take out from here is that these CSIs and generally the terminal signals are open-ended. So it means that these styles will continue until we get an instruction from the shell to reset them. So that's why world is still blue. If you've ever had like a terminal application crash on you and then you saw stack trace in blinking red, then this is the reason. As you can see in the slide, you can try this yourself with the echo command. You can give it a flag so it doesn't escape all these things. Then you can like play around with styling the terminal. So this is all well and good for like line feed, to be able to send line after line to the terminal and have it display it in its scroll buffer and such. But the terminal also has the ability, as I'm sure like you know, to be able to display textual user interfaces, such as Vim and Top. So aside from styling instructions, we need a few basic things. We need to be able to send cursor movement instructions to tell like the terminal to move its cursor to this column and this line. Then we need like box drawing characters. We can see the table of them here in the picture. These characters are part of the Unicode standards, so they're like first-class characters, and they're used in order to draw UIs. You can see some creative examples on the bottom right. These are all made of characters. In addition, if we want to have programs such as Vim, Nano that like provide text editing, then we need like something that's called scroll region. This is mostly if we want to display like fixed content, like a status bar on the bottom or on the top or something of that sort. So why do we need the scroll region? If we imagine like scrolling the terminal, like having the line buffer of sending a line and sending another one and adding a new line, when we fill the scroll buffer of the viewport of the terminal, then once we add a new line, what actually happens is, as you see here, all the lines are shifted like one to the top, and an empty line is created on the bottom. This is nice, but it does like present some problem, as we mentioned, for fixed content, because then this happens. If we see here on the left, we have like let's imagine the fixed content, like status bars on the top and bottom, and and then when we add new line, they're like shifted upwards. So that's not what we want to do. This is a self-portrait, by the way. So the solution to this is scroll region. Scroll region is like a CSI instruction, just like the styling instructions. This is, as you can see here, the instruction is R. It tells the terminal that from line 2 to line 4 is the scroll region. So this is something that needs to be treated just like the scroll buffer, and the terminal does the rest. So whenever a new line is added, assuming the cursor is within the scroll region, then like everything above and below it stays the same, and like it kind of does the right thing in the middle. The astute watchers here will notice that the CSI instructions in general are 1 indexed rather than 0 indexed, and you can imagine how fun it is to program if you want to like position lines in vector, for example. Something to keep in mind. So after we talked a little bit about the theory of how a terminal emulator works, I want to this is some code from Mosaic, because Mosaic also has an internal terminal emulator that we use for the panes themselves. And I want to talk a little bit about how we implemented it. So I'm going to take the annotation stuff. So I want to start with how we represent terminal character. A terminal character is like we both keep track of the char, the character itself, and its styles. So the reason for this is that as we remember, the CSI instructions are open-ended. So a terminal character might be might have a blue background, for example, but that might be something that happened 200 lines ago. So when we want to render it to the user, we don't want to have to look through all of our scroll buffer in order to figure out what style it is. So we keep track of it on the terminal character. On the other hand, we also don't want to keep these ANSI strings on the terminal character. We want to interpret them. The reason for this is that if we kept a string on the terminal character, then each time we allocate a terminal character, it would happen on the heap rather than on the stack. And that is a very, very big blow for performance. That's how I implemented it at the beginning. And moving to this sort of structure really had a performance boost. So the character styles here, we have all the kind of styles that kind of override each other as options, and the ANSI code structure below them. And when we render these characters to the terminal, we kind of try to do it intelligently, not send a styling instruction for each character, because that would be very wasteful, but do kind of the same as how we got it from the PTY to when the characters start being blue, we send the blue CSI and then continue on until it needs to be changed. We can diff the previous style. These characters are all of them are placed in a row. A row has the vector of these characters and also a flag of whether it's canonical or not. A canonical row is a row that the terminal told us is a new row. We got a new line from the terminal. This is important because if you imagine expanding the terminal window and having to unwrap lines, then we don't want to unwrap lines that are canonical, because then you'd have like something that clearly needs to be the start of the line, like stuck to the line before it, and that's not what you want. Moving further up, we have the grid. The grid has the viewport, which is what's displayed currently on the screen of the pane, which is a vector of these rows. We have the lines above and the lines below, which we use for scrolling. And we also keep track of the cursor, which is just the XY coordinates of the cursor on the screen. If we have a scroll region, we keep track of the top and bottom line of the scroll region, and we keep track of the width and height of the grid to be able to like resize it as needed. Yeah. Like, by the way, feel free to interrupt me with questions and such if anything is unclear. Going to take a drink of water and then let this sink in for a moment. And yeah, now if Zoom will give me my mouse back, I will move next. So this is like kind of how a terminal works and how it is implemented in Mosaic. Now, I want to like move, like zoom out and look at what a terminal multiplexer is. So taking Mosaic as an example, Mosaic takes the place of the shell, but of course the shell can also defer to it, of course, like you can start your terminal and start Mosaic. And it stands between the, on the other side of the PTY from the terminal emulator. And then it does the splitting into several PTYs on its own, and decides, like it takes all the like the ANSI VT100s, bare text, etc. instructions that we get from the PTY, creates an internal state, and then decides how to draw that state to the terminal emulator. So if something changed, for example, in this page, oh, I'm sorry. So if, there we go. So if something changed in this pane, then it would go to, like if we got something on the PTY, like a new character was added, it would go to that part of the screen where it knows the XY coordinates of the pane, and it would enter the, the character there. What we also see here is the plugins that I kind of touched on before. The plugins don't have their own PTY. They're just they just have an internal API that we use to communicate with Mosaic, and we don't need to have the operating system in charge of our communication pipe. We just do it on our own. So yeah. So if we look at the architecture of Mosaic itself, like we zoom into the Mosaic part of that diagram, then Mosaic is built out of three main threads. There's the stdin threads, which is in charge of getting the user input from keyboard or mouse. The PTY thread, which is in charge of opening all these PTY connections with the operating system, keeping track of them. It has like async streams that it uses in order to read them, so they won't block each other if we get a lot of characters in one of them. And we have the screen thread, which is in charge both of deciding what should be on screen, which is the focus tab, which terminals should be drawn, and also of keeping track of the state of these terminals. So when I say state, I mean what text is displayed in them, like if you have a top window open, then how it looks, all the characters that make it up and such. Everything that we can use in order to render this to the user's terminal. When I created this, I elected not to use shared memory in the form of ARC mutex, but instead for all of these to communicate with MPSC channels. In case you haven't used MPSC in the past, it stands for multi-producer single consumer. It's a way to send messages fast in memory without having to for example, with an ARC mutex, you have to lock a certain part of memory, and only one thread can interact with it at a time. And when another thread wants to talk to it, it has to wait for it to be released. So this is both using an MPSC, it just shoots the message. It's both faster, like it's more performant, which is especially important if we imagine the relationship between the PTY and the screen. Like imagine you're tailing a long file and like characters keep coming all the time. You don't want to like have any locks there. But it's also like kind of critical if we want to eventually move these threads to different processes. So like it will be much easier to already be able to just switch out the MPC channel for IPC, for example. Let's take a look at an example of an action that can happen and how like it moves between threads. So we start with the stdin thread. We get control GM. It's kind of a temporary shortcut. We're still working out the shortcut. What it means is open a new pane wherever. Like don't split anything horizontally or vertically. Just find the largest free space and open a pane there. So the stdin thread figures out this is a command that is directed at Mosaic. It like sends a message through the MPSC channel to the PTY thread, telling it to spawn a new terminal. The PTY thread adds a new terminal to the list and then sends a message to the screen thread, telling it I added a new, like it basically forwards the message. Like it tells the screen thread, hey, I added a new pane. This is its ID. Do your thing with it. So the screen thread finds the like largest empty space and sends like a message back to the PTY thread, telling it resize this ID to this size. You'll remember that this is important because the PTY, one of the state that it keeps is like how large the like the terminal window is, so that like UIs will be able to query it. So then PTY threads talks to the OS and tells it to like change the size of the like PTY that it opened before. So this is one example. We can also imagine like an example with the stdin thread communicating directly with the screen thread. For example, if we want to resize a pane, it would send this command to the screen thread, and then the screen thread would send the resize to the PTY. This was all, this is like nice, but like after I created this, when other developers started hacking on the project, then this like started to be a little bit confusing, especially if you're a developer that isn't like intimately familiar with how the app works, and you get like a stack trace, like a crash. If we can like imagine in this process, like say the screen thread crashes because of an integer overflow or whatever, the stack trace that you'll get only represents stuff that happens within the screen thread. So you don't really know this whole story of where the message got and what initiated this and such. It can be like more complex examples than this. And generally, like debugging it is not the funnest thing in the world. So one of the other people on the team implemented like an error handling mechanism for this. What we did is we took the MPSC senders, we wrapped them in like kind of our own custom struct that you can see here. We kept the same API, so you can still use them to send messages to other threads, exactly as you could before. But you can also update them with a custom error context. An error context, like it's not displayed here, but it's basically like just textual lines of or enums that can be serialized into textual lines. Of like. I got keyboard input. I came here. I opened a new PTY. I opened a new pane. And this is like kind of forwarded between threads. And whenever we get an error, then we forward the error context into a panic hook so that we are able to display like kind of a nice story before the the stack trace of what led us here to be able to more easily debug this. Moving on. Now I want to talk a little bit about what I alluded to since the beginning of this talk, which is our WebAssembly plugin system. The reason we chose WebAssembly is that if we want to write plugins for for Mosaic, we don't want to have to if you can imagine the status bar, for example, which is a plugin that we saw before. We don't want to have to recompile Mosaic in order to load it, in order to add more functionality. So WebAssembly allows us to precompile Rust code into a WebAssembly asset and then load it at runtime into an application. So the UI for this can be as easy as taking a URL of a WebAssembly asset in GitHub releases somewhere, loading it into your application, giving it permissions, and then you have a pane. You're already running application. It would, WebAssembly also allows us to, as I said, write plugins in any compiled language. This is especially useful if you want to take existing applications and turn them into plugins. And it also gives us built-in sandboxing. So applications would also not be able to affect other part of the application, of the Mosaic application, only through API. And also not easily affect other parts of the system, the computer do, rm-rf/ and such. So how does it actually work? In our philosophy, each plugin is a separate pane, like you've seen with the status bar, for example. If you want to have an experience that is multiple panes, then you write two plugins that communicate with each other, or one plugin that you open twice and does different things depending on what it is. We have a message, or we plan to have message buses and such. The WebAssembly system has been merged into main, I think 2 or 3 weeks ago, so everything is kind of new and shiny. You write a Rust application or a Go application or an assembly script application or a C++ application, and then that application just renders itself through stdout. It can be as simple as a print statement, or it can use all the ANSI VT100s goodies that we talked about before. If you want to do that, I would warmly recommend using a framework, which would make your life a little bit easier. If we're in Rust world, I very much recommend TUI, which is a really cool terminal UI framework. And in order to have this compiled WebAssembly assets interact with the operating system, we use something that's called WASI. In case you haven't heard of it, I think, don't catch me on this, I think it stands for WebAssembly Server Interface. And this allows the application to use its native file system interaction module and talk to the operating system, but only to the parts that you give it permission to talk. If I'm using it to code, I would only give it permission to talk to the to my repo, essentially, to the place on my hard drive in which I hold it. And then, if it does crazy stuff, I have it all in GitHub or in Git somewhere, one should hope. Right now, we tried, and it works with interacting with the file system. In the future, we hope, I'm just not sure what the state of WASI is in this area, but we hope to have it interact with a network, for example, and other OS layer stuff. To give an example of this, I'm going to start Mosaic with a layout that loads a plugin. Right now, that's our way to load plugins until we create some sort of UI that does this. If you remember from at the beginning of the talk, I showed my development environment, and I showed like Ranger, which is the file system explorer. Our first plugin written by a member of the team is called Strider, which is a Ranger clone. As you might notice, we are a little bit of Tolkien geeks. Strider, this is a WebAssembly plugin that is not running on the operating system. It's running like as part of Mosaic. And one can use it to like explore the file system, go up, go down, and even use an API in order to open panes in Mosaic. What happened here is that the API sent the open new pane command with a file path, and Mosaic used the system's default editor. In my case, it's Vim, in order to open a pane where it has the most space. We can do that. We can open one. We can open like, I don't know, this one, for example, and it opens new pane, and we can do like all the things with that. So this is about how we do it with WebAssembly and what we have right now. These are the two plugins right now in existence, but in the future, like one can imagine a lot of stuff that we can do with plugins. Personally, the plugin that I'm most excited about, that I hope someone will write in the future, or maybe I will get to it, is like have a Rust analyzer or cargo check. Like if you can imagine, sometimes if I like when I write Rust, I sometimes get use after move or use after borrow error. And the error is like awesome, but sometimes the lines are like 100, 150 lines apart, and then I have to like track it and go up and down and such. So I can imagine a plugin that I would able to interact with and press, and then it opens a pane with like my default editor on the line of the error, opens several panes and saying the error happened here, here, and here. And you know, imagination is the limit. I'm not going to go very deep into this code, but this is, I just wanted to show like the example plugin, which is our status bar. And I mostly wanted to show you that like it has a kind of not very trivial functionality that is written in very little lines of code, because Mosaic does a lot of the stuff. It has pagination. It has like a conditional rendering of like it renders different stuff depending on the size of the pane that it is, which comes from the size of the terminal window. And it interacts with user input. We have currently a library for Rust for writing plugins. We call it Mosaic Tile, which gives you a trait that you can implement. And once implementing that trait, it has like init to do some like startup stuff, and then draw, which is called every time that Mosaic needs to render you. And it gives you like the size and such, and also allows you to handle keys and such. This is all on GitHub. You can check it out. Like there is a link. Something else that we want to do with our architecture. I mentioned at the beginning of the lecture that terminal multiplexers, TMUX, for example, can do like a sort of client-server thing, which allows you to connect to a session, work, open panes, do your stuff, and then detach from it, close the terminal window, open the terminal window again, reattach to the session, and continue your work. This is especially powerful if you're like on a remote server, for example. This also has the added benefit of allowing more than one client to connect to the same session. So if we can imagine creative uses for this, then like my favorite is obviously peer programming. I think it can be really fun for 2 or more people to connect to the same place and work not only on the same code base, but on the same code in real time, to be able to like go to a tab of my friends and seeing what they're working on in real time, like as they type. And also like if we imagine having like plugins that facilitate this, then like Mosaic can actually help you do this. For example, we can imagine a plugin that like knows when one person is editing a struct and another person is editing the implementation of that struct. And then it can like give a certain warning, change the color of the status bar or something, tell you, hey, maybe you want to like check with the other person to make sure you're not like contradicting each other. Yeah, I think the fun thing about the plugin system is that probably the coolest plugins are the ones that I do not think about, but the people implementing them will. In the future, like this kind of gets into like science fiction territory, because these are things that I hope will happen. I have a general idea about how they can happen, but like I don't see it yet. I'm saying it here not because I'm saying this is like my plan or my roadmap. I'm saying this is something that I want to happen and I hope is possible. So just to have the right disclaimer about it. I would like to have different adapters for Mosaic. At first, to be able to connect to it, not just through a terminal emulator, but through, for example, there are specific terminal emulators, if you know them, like Terminator and iTerm2, which like kind of have their own like multiplexer pane thing, which is part of the application itself. I think it can be cool to have that backed by Mosaic, so that in the Terminator or iTerm2 panes, one can see the same thing as another person connected to that session and terminal. I also think it can be cool to do the same thing with like the X Windows desktop environment, to be able to open different terminal windows for each terminal pane of the session that you're connected to. And maybe if we're taking the plugins, maybe we can even find some way to interpret the textual user interface into an actual interface that will be displayed on X Windows if one is connected with that client. And maybe even then find a way to write a VS Code plugin that would like kind of sync it with a Mosaic session, and then one person can use VS Code and another person can use a terminal emulator and such. I would also like to extend the layout system. Currently, we have a layout system in Mosaic that one can like start it with an argument to a YAML file. The YAML file describes a layout, which is how I want my panes to be arranged on the screen. I would like to extend it and create some sort of language that would allow one to, for example, borrow a page from web development and be able to change the layout depending on the size of the screen. So when we resize the terminal window, not just to have like the panes resize themselves relative to how they were before, but for example, we say, okay, if this pane becomes too narrow and it doesn't make sense to show it, maybe we will like move it down, or like maybe we'll remove it entirely and have some like text message saying there is another pane here that is hidden, do like scroll to access it, or whatever. Another idea that I've had is to use Mosaic in order to facilitate rendering like images and video in the terminal. Maybe you've seen this in some terminal emulators support letting you do like cat to a PNG or a GIF image, and then having it displayed in the terminal. I haven't dealt with this, like with the implementation of this directly, but as far as I could figure out, there are a few different ways of doing this. And if you want to write an application, you need to like either choose to support one, or like depending on the terminal emulator of the people using your application and the operating system and such. So we have to either support one or detect what it is that the user is running and then like kind of support all of them, like we used to do in browsers in the past. So I think it can be cool for Mosaic to kind of like, I would not want to create another protocol, but I would like to be able to like make it easier to support all of them in one way or another. So this is kind of how I envision the future architecture of Mosaic, having several clients of several kinds connected to the same Mosaic instance, running several sessions. So some of these clients can be collaborating, some of them can be like working independently. and Mosaic having like different connecting to different shells and PTYs and plugins and such. It can also be on a remote server. It can conceivably even be a service on the net that you connect to, keep your sessions and such. So after we've talked about like the idea behind Mosaic, what it is now, we've shown some demos, went to the technical part. Like every open source project and every like project in general has like kind of a story behind it. So I want to share you a little bit how the beginning of Mosaic was for me. When I started creating it, like a month or 2 months after it, like the task was daunting. It was big. It was far bigger than I thought it was, than I thought it would be, as happens a lot to us software developers, as I'm sure you can relate. I wasn't close to giving up, but I was very frustrated. So I talked to a friend who is now he was the second ever maintainer of Mosaic. And he advised me to open the project up. Just take it as is, make it public, get other people involved. I eventually took his advice, but it was one of the harder things that I did because, you know, of course, the project is not ready. It can't be shared before it is ready, but that wasn't the right way to think about it. Sharing the project allowed other people to get involved, like kind of on the ground level, and made the project like not mine, but a team effort. It would not be close to where it is today. Without the team, it probably would not be. So I'm incredibly grateful to that advice, and I want to give that advice to you. If you take nothing else from this talk, please remember that if you have a project and you're kind of frustrated about it, before giving up on it, open it up. Like when I opened Mosaic up, it was like, there were some files which were 2,000 lines of code long. It was like, really, I kept feeling that I have to apologize for this code, but that's not, in my opinion, that's not the right way to think about it. Get other people involved, like don't work alone. As promised, some problems that we're working on today, where the project is. I'm mostly concentrating on fixing so-called compatibility issues, which is places where like you would work with Mosaic, you would work with like lots of different panes and run stuff in the panes, and then stuff would either crash or not behave correctly. The colors would be wrong, the lines would be wrong and such. So I'm fixing these, like squashing them one by one. This effort is kind of close to its end. When like Mosaic's like it, like I'm saying this carefully, but it's starting to be in a pretty stable place. There's still work to do here if there's something that interests you. I would also want to flesh out the layout system. As I mentioned before, doing all the like conditional layout and creating like a domain language inside of the YAML files. I think it can be like a pretty fun project. I have the idea of supporting multiple terminal windows for session. So if you have like multiple screens, for example, you can open a terminal emulator in each one of the screens, drag panes between them, kind of figure that out. I think that can be a fun thing to do. And then, of course, more plugins. In the team, we had ideas for like a chat plugin that would allow people connecting to the same pane to chat. If we get WASI networking support to happen, then maybe even connecting to different chat clients and having them in Mosaic. There's the Rust Analyzer plugin that I mentioned. People on the team also want like a Kubernetes cluster explorer. So if you have like a Kubernetes cluster, you would load its configuration into Mosaic, and it would like open panes to all the right places and such. And you like, I think it like can be a fun way to onboard other people under the team. And of course, as I mentioned, I think the best ideas are ones that like neither me nor people like currently on the team will be the ones to think about. I would like to end with this quote from my favorite software philosopher. Douglas Adams wrote in A Salmon of Doubt, should not have to be tyrannized by application developers who don't know the first thing about how actual people do their actual work. We should be able to just pick up the bits we like and paste them in. And I think it could be pretty cool if this becomes like a workspace that people use, can just take parts of applications that they want, paste them in, and work the way they want. Thank you very much. Thank you to Russ Linz for having me. Thank you for your time, for listening to this talk. If Mosaic is something that interests you, please visit us. I'm around. You can follow me on Twitter. I sometimes write about terminal stuff or on GitHub. Yeah, please join by. We also have a Discord server if you want to learn more about the project and how you can get involved. We're a friendly and welcoming bunch. No matter your experience level, we'll be happy to have you. And I'll try to stick around on the Russ Linz Discord server in case you want to talk to me or have questions, or you can ask me right now. Yeah, thank you very much.
Thank you very much, Aram. Thank you very much for this awesome talk. It was super interesting. I learned a lot of the things that you showed about terminals many, many years ago, and I really got nostalgic because I forgot about many of them, because in the last years I was just using VS Code, and now things start coming back. And yeah, I love your project, and I especially love your ethos for open source, being open, sharing with the team, opening up. Really a big thank you to that. You probably haven't seen it, but in the Discord server, a lot of discussion is going on. It is a topic that you touch the heart of lots of the developers here. I would like to relay a bunch of questions to you here. The first one is more a big congratulations. Carl wrote, the talk is fascinating, and a lot of people gave a +100 to that. So we really enjoyed your session. One of the first questions that I recognized wasn't really answered in the Discord server is Fuzzy was wondering if it is possible to write such a project without lots of unsafe code. Can you talk a little bit about your use of unsafe code inside of the Mosaic codebase?
Interesting. So my relationship with unsafe Rust, quite honestly, is I've never had occasion to use it. If there is unsafe code, no, I'm sorry. There's a bit of unsafe code in our interaction with libc, doing ioctls and such, but that's because we kind of have to. But I mostly relay to other libraries to do that when possible. To Nix, for example, a good library that kind of wraps it and does it for you. There is very little unsafe code in the project that I'm aware of, at least.
Mm-hmm. That's interesting. That's really interesting. I think that will surprise some of the people here in the Discord server, because I guess that many of them assume that it has lots of unsafe code. So viewers, if you have follow-up questions on that, shoot them, let them come in, I will relay them. Harold is saying he loves Teammate, and he asks whether a function for terminal sharing is also planned. Was that the thing that you told us about with the client-server architecture, or can you make a general comment on that?
Yeah, I also think Teammate is amazing. It was kind of an inspiration for a lot of stuff. Yeah, that's what I was talking about with the client server. That's a big thing in this project, is being able to collaborate on code and have multiple people connecting to the same session. A Teammate, as far as I'm aware, is using a fork of Tmux, and it has some issues with, for example, if different clients have different terminal emulator windows. It would use the it would kind of make itself the size of the smallest terminal window connected to the client, which is a good solution. But one of the things I see for Mosaic in that regard is the layout system. So if one person would have a small terminal window, and another person have a larger one, they can see like an experience that was built for that, kind of like when that we have in the web. So that's something that I think can be improved over how Teammate works right now. But definitely Teammate is also a service, which is like pretty cool. And I would not want the responsibility of running a service, but if someone wants to, like when we have this functionality within Mosaic, which is something that someone on the team is developing as we speak, like the next big thing that we're doing, then yeah, that we would be very, very happy to support that.
Okay, thank you very much. Thank you very much. During your talk, it seems that Harald was really downloading your code, immediately compiling it and testing it. And he was asking about resizing of terminal. He writes that maybe there are some issues about resizing of terminal windows. And I will just read it out loud because I'm not that familiar with that one. Processing of signal, SIG-winch, is not there. I think every system will have its own handling. Can you elaborate on that?
Yes, very good question and very good find. SIG-winch support is currently not, like, this is one of the things that we want to do. A member of the team is working on it right now. I agree, it is super important. SIG-winch, in case you don't know, for those who don't know, is like an operating system signal that tells the terminal emulator, or it tells the program running inside, like the shell or Mosaic in this case, that we want to like resize the terminal has been resized. It's like you need to redraw yourself or do the right thing. Mosaic doesn't support it currently, and we're currently working on it. The main issue, by the way, is not actually supporting SIG-winch. There are cool libraries for that I've used in other projects. The issue is that there is a lot of like product work to be done. For example, to decide, we don't have like a way, we don't have a minimum size for a pane. So one can imagine that can be problematic if you like resize the window and start and suddenly one of the panes need to resize to like -1 columns or 1 column or like whatnot. So most of the work that needs to be done in that area, and it's work that's being done at the moment. So good catch.
Okay, thank you. By the way, Carl just had a really good idea for a plugin. Imagine a plugin that uses WebRTC to hook up a Csi session to share your terminal, for instance. It was, I think that might come to a really, really nice plugin. But he also has a question to you. I would like to just read it because, yeah, it comes, I think the spirit comes across. In terms of threading, how does your system, Mosaic, compare to Tmux screen? Carl doesn't know if those use multiple cores, and for no reason he absolutely wants to use the fastest thing available, even if he might not notice a 1 millisecond difference. So I think his whole question is around performance. Do you have tests about that or comparisons about that?
Just to make sure I understand the question is how Mosaic compares performance-wise to like Tmux and Screen and such?
Yes, I understood his question like that, yes.
Okay, so good question. This is, I guess the answer is what are we comparing? Like, are we comparing the, like how fast it takes from the moment when I press a key until it appears on the screen, which is also the same as like if I scroll a lot of text and such. Like if I resize a pane, how fast that is, opening a pane, how fast that is, like it can be a lot of different stuff. I will answer all of them. Right now, we are less performant than Tmux. Tmux, if you've used it for a few years, I've used Tmux. I don't remember, like, I don't want to say exactly the number, but many years ago, I've used Tmux, and at the beginning, it was like not very performant. It was very clear when, for example, you did demask or a command that gave you like that shot a lot of input into the terminal. It was very clear that if you do this outside the terminal, it will be faster. right now, the people at Tmux did like amazing work. And to my eyes, at least, there is no difference between like scrolling in Tmux and scrolling in like outside the terminal, but maybe there are benchmarks for it that I'm not aware of. Mosaic, we are not there yet. I did a lot of work on performance, and this is mostly involving, I talked a little bit about data structures, about allocating the terminal character on the stack rather than the heap, and things of that sort. It also involves like which parts of the screen we render, and there's a lot of things that can be done in that area. So that's, I think, the major performance issue that users would notice, and that's not up to par yet. If this is work that someone is interested in doing, that would be amazing. Otherwise, this is definitely something that we'll get to, but my opinion right now is that it's more important for the terminal like not to crash, or for things to be displayed correctly, and for them to happen fast, but that doesn't mean it's the right opinion. As for resizing terminals and such, there are also like definitely a lot of optimizations that can be done there. I think I didn't really get a chance to get into it, but in the like, I'll scroll up to the grid structure that I showed above here. If we look at the grid structure, when we resize the terminal, we only resize the viewports. The lines above and lines below, we try to like unwrap the lines as we move them up and down. The reason for that is so that we won't have to like resize the whole scroll buffer whenever a pane is resized. I'm not sure how Tmux handles this, to be honest. So it's hard for me to compare, but to my eyes, like it's pretty fast. So maybe it can be interesting to have a benchmark about this.
Yeah, Carl just clarified that he is even more interested in input latency, not so much in printing out lots and lots of lines of text or something like this.
I use Mosaic every day, and to my human eyes, I don't see a difference.
Yeah. Okay. Thank you very much for that. Aram, there are many detailed questions and lots of ideas. Some of them are really serious, and some of them are just funny. For instance, one person suggested to just take Vim, compile it to WebAssembly, and simply make it a Mosaic plugin, something like this. So my question to you is, we have another question coming in. Harald asks, can you detach a session? I'm not sure if I can understand the question. Can you understand the question?
Yeah.
Okay. Yep.
So detaching a session, if I understand it correctly, it's like it's the terminology Tmux uses in order to do the connecting to a session, detaching, closing your terminal window, and opening another terminal window and reconnecting. Is like
yes. He says yes.
Yes? Awesome. Right now, we are not able to do it. This is the next, the next big feature that we're working on. A member of the team is working on, in order to do this, we need to, if we'll go, we need to separate this architecture to different processes, because we need to have a server process and the client process. The server process needs to kind of keep the state of what's happening in your session, and the client process needs to be able to copy that state and draw it to your screen, and then interact with it and change it and such. This is work that we're doing now, and we're doing it exactly for this reason. So yes, it's in the cards.
Okay, very good, very good. Thank you very much. Aram, will you stick around on our Discord server to chat a little bit with people who have some detailed questions or maybe some suggestions for you? Do you still have a few minutes?
Sure. I don't have super much time, but I will stick around for a little bit.
Absolutely. And you can get your congratulations there, because I'm pretty sure many people will give you a thumbs up, because it was an awesome session and we really, really loved it. Thank you again for visiting us, and we will crossing the fingers for your project, because it sounds awesome, and I will definitely give it a try, and I'm looking forward to that.
Amazing. So cool. Thank you very much for having me. I had a great time.
Thank you. Thank you, Aram. And thank you to everybody watching today's meetup here, a Rust Meetup Linz. Thank you for watching. We hope you enjoyed the content. We hope it was interesting. And we are going to see each other if you want in February again. We have already fixed the speaker lineup and we will publish the speaker lineup for the Rust Meetup Linz of February in the next few days. So take a look at our meetup page and take a look at rust-linz.at and you will see the great speakers that will be here for you in February. So with that, I would like to close today's meetup and wish you all a very nice evening. See you all in February.